had a lot of AWS semi shout outs in the first keynote this morning, so we'll see how it goes. Great intro from Quinny Pig saying that all other talks are wrong. Hopefully that's true. We're going to talk about creating effective Docker images. Now that I've gotten my not clicker to work, so what are we talking about? So a little bit of level setting. We're going to cover how do layers work. We're going to talk about some basics. We'll do high-level practices for Windows. We'll go through some Docker files. We'll go through some language-specific tips. We'll talk about tools, and then we'll talk about looking forward to the future. So this is intended to be, if not intro, at least pretty. The goal is that I want people to be able to leave with tools that they could use in production right now. So not something that it takes a couple weeks to research and implement, but hopefully, regardless of what kind of level your container infrastructure might be at, that you leave with something that you could put into practice. So should be something out there for everyone, but we'll start off with some of the basics. So to start it off, what are container layers? So Docker containers are built as stacks, right? So you have the beginning, which is a stack of read-only base layers. So that's your base image. Obviously, read-only, you can't really do anything about it. On top of that, you get a really thin read-write layer. So that's where everything that you commit when you're running your container, everything happens there. And then what you do in that thin read-write layer adds up to your final image size. So your base stack plus what you've committed in your read-write layer is the final size of your image. But why do I actually care about how many layers I have? So I used to deploy a monolith, and obviously that could be pretty big. So why do I care about all these tiny container layers anyway? More layers, a larger image. So it used to be that if you were building a monolith, you deployed, if you were lucky, maybe once a week, or you had a giant stage release and it happened every couple of weeks, every month. But if you're deploying containers and with that probably microservices, that adds up really quickly. So your 2 gigabyte image that sounded really good when you read a blog about it on Medium is probably not so great when you have hundreds of them and you're trying to deploy them every couple of hours. So it adds up really quickly, both to build the actual image and then how to push and pull it from a registry. So how to get it onto an actual server. It also means, so usually I give this talk to an audience of mostly developers, and you can see some of them sitting there thinking like, ooh, well, this doesn't sound like my problem. This sounds like an ops problem. My problem is just my application, but this is DevOps days. So we can think about stuff. Well, everyone should think about it because everyone is a DevOps person now. But if you're one of those people, then think about the security also. So the larger the image, the larger the attack vector. So the smaller your image, so the less packages you have on that image, the less things there are for someone that is less well-intentioned than me to attack. So safety first, smaller is safer, but also faster. So this sounds great. So how can I reduce the number of layers that I have? Keynote and PowerPoint apparently really hate my GIFs, so it was funnier when this was a GIF. So just imagine in your head that this was a GIF. The layers for these Docker images are a lot like preschool, right? So what do we learn in preschool? So sharing is caring. So if I have a block, I can share it with the other kid that also wants to play with the block. So use these shared base images wherever possible. So that means if I have 2 Node.js containers and they both have a lot of similar requirements, they can use a shared base image so that it saves me space on the host itself and that they can build a little faster. Obviously, limit the data that I write to that read-write layer, chain my run statements, and then prevent my cache misses for as long as possible. And we'll dig into all of these in depth. So hopefully, if you're sitting here, you know what a Dockerfile is, but you would be surprised at how many people have skipped the whole intro chapter and says, I don't need to know any of this. Let's get straight to building. So instead, because it's mandatory, I will cover all the basics for you. So a Dockerfile is a series of instructions for building an image. So pretty common format. You get it it's like argument or instruction, and then what you're actually doing. So run X, add X, copy X. So I stole this from Wu-Tang, and I actually like this joke so much that I bought the Wu-Tang font. I did not expense that. That was a personal expense. So this is the actual Wu-Tang album font. So I've stepped up my Photoshop game. why do you care about my joke? So cache rules everything around me. So for Docker containers, it's all about how long I can use the cache. Docker has some funny caching behaviors. So basically, everything that's the same up until something that's either different or is a run statement, you can use the cache for. But there are some things where the command is the same, but the result is intentionally different. So an example might be pulling from a Git repository. That actual command is never going to change, but I want the result to be different. So sometimes I'll need to break the cache myself. But in general, I want to hold off breaking my cache for as long as possible if I want my builds to be faster. So we'll look at some tips for how you can do this, but I can write the order of my statements differently. I can chain them together, all in the name of getting me a little bit of disk space. Why do I care about disk space? So I'm starting to think that maybe I should filter people out for whether they'll actually enjoy the talk or not by saying I'm just going to talk about disk space. Why do you care about it? So in real life, disk space is something that's it's not super glamorous, but it has far-reaching and unintended consequences when you ignore it. So for example, if some of you have possibly been on call, I was on call right up until I went to Amazon. And in real life, when you've definitely talking about a friend here and definitely not me. So you move over your monolith to containers and you're really proud of it. You did a great job. You definitely read all of the documentation. And then 2 o'clock in the morning, your PagerDuty starts freaking out. And then you're like, oh God, what is this? So PagerDuty's freaking out. It's sending me all these messages. And then I look at it and it's like, well, all of your cluster hosts are out of disk space. And then I'm like, all of them. And then you go on and then you realize that all of these beautifully handcrafted artisanal container images that I've spent so much time working on are actually quite large. And all of those container images and my beauty of continuous deployment have added up to taking up all of the disk space across all of my cluster hosts. So don't be me or my friend or whoever we're talking about. But this is something that it doesn't sound super exciting. So what's more exciting is building a cool application. But stuff like this really adds up. And it adds up to how fast your deploys are, how quickly you can ship features to customers, but also in how you can not get paged at 2 o'clock in the morning, which is important to me. So first step, so let's walk through some examples. So let's start with the Dockerfile. So this is, by the way, it is fine. You can run it. It actually works. There's some reasons why it's not good, though. And this is exactly where I would have started when I first started working with microservices. This is exactly what I would have started with. It's fine. It runs. And I know that my thoughts would have been like, this is great. But there are some ways that this is not great. So the first one, I can make this a little bit smaller by choosing a different base image. So in the previous slide, I did what I knew. So my monolith was maybe running on some Ubuntu servers. So I said, great, here's a Docker image for exactly the operating system that I've been using. This seems friendly. I'll do this. But there are better options out there. So my first step, this is how large my stock Ubuntu image was, so 458 megs. If I picked, you saw that my example built in Python. If I pulled an image that was maybe built for Python, it's 86.8 megs. And the people at Alpine are a little crazy, and I'm sure they've made this like 20 megs by now, but at the time where I pulled this for my example, it was 86. But I saved a bunch of space just by changing my base image. I didn't really have to change anything else. So that's it. And then that image then builds a little bit faster, ships a little bit faster, takes up a little less space on my hosts. There are tons of options out there for pretty much anything that you're building, right? And all of them will have space trade-offs. We'll talk about why maybe you don't necessarily always want to use one of the more minimal images, but if you know what you're doing, if you know your packages, if you can install them correctly, there's an option out there to help you build and ship that feature faster. So when do I actually want a full base OS? So all my slow examples were picking on Ubuntu, and I actually do really like Ubuntu. When do I want the full thing? Security is one of them. So I'm not just downloading a strange operating system I found on the internet. Safety first. 2 is compliance. So not everyone works at a startup. And in a lot of cases, you only have a prescribed set of rules that you have to follow for your development. So maybe you work at a bank, maybe you work at a company that's just not a tiny startup, and you have to follow the rules of corporate IT. And then the final one, and we'll look at this in depth with a Ruby example in just a little bit, but ease of development. So some of these minimal images, they had to get rid of something in order to become smaller than a full operating system. So in the case of some of those images, I sacrificed a package manager. In some of the other ones, I sacrificed, so Ruby builds with many supporting gems to make your process as easy as possible. To get a minimal Ruby image, I sacrifice those extra gems and I install only what I need. So this is great, but it requires a little bit more work. So if you're just getting started, maybe sometimes easier to start with the stock example. So here's my original Dockerfile with my original Docker image. This is probably literally almost word for word what I would have started with, and still fine. Here's my change though, and you'll notice that by changing my base image, I got a second supporting change also. So I changed my base, but then one of my lines disappeared, and that was my apt-get line that was installing all of my extra packages. I don't need them anymore because those packages were setting up my Ubuntu image for a Python application, and by using a base image that was written for Python applications, I already had those installed. So all I need to do is install my actual app requirements. Same with cache invalidations. So the least number of times that I can invalidate the cache, the smaller my image will be. Once I've invalidated it, there is no going back. So if I know that nothing has changed up until that point, let's hang on to my cache as long as possible. So here, I saved myself an extra step. I copied over my requirements first before I built, so I can do that. So then I only rebuild if my requirements have changed. A little recap of our progress so far, right? So layers, file system differences, they add up really quickly. So the more layers that I have, the bigger my final image will be. We're going to cover Windows really fast. We're basically getting to a point where everything is pretty much supported equally. A lot of people don't have can't use a green field kind of start for their containers workloads, right? That you came from an area where you either had a monolith that you had to break down, or maybe you didn't have Linux. Maybe you were running your workloads on Windows, and we're moving to a place where those are all kind of supported in the same beautiful, happy family. So there are some tools out there to help you convert your existing Windows images. It is very cleverly called Convert to Dockerfile. But then it lets you run it the same way that you would a Linux container. We'll talk about the implications of that, but this ultimately means that I can run and build my containers exactly the same way. So once I've converted it over from Windows, it is a Dockerfile like any other, and I can build it and run it just the same as I would a Linux image. Some gotchas for Windows. Watch the path you build. So when Windows will work a little bit differently when you're converting it. So if you build those paths, your image will be unusably large. I'm actually even not sure it will finish at this point. I know that there's pull requests open. Hopefully some of them have been merged around preventing you explicitly from building some of those paths. But be very careful what you build with Windows. But you also have to be careful on how you install them. So you have MSI installations on Windows, which helps you install an application. And then on Windows, you also get a really way that when you know how when you click it, you can just uninstall it. So there's like the installer and the uninstaller all at once. This will come back to haunt you a little bit if you're installing them in containers. So if you install them with MSI, Windows will save those files for uninstalls, which is how the magical uninstaller works, which is great from a desktop, not great in a container. So we'll look at the trick in a second for Linux, but in Linux, I can use the same step and have those layers basically not committed. So if I install, use, and then remove a package all in the same step, the package that I used and removed is not added to my final image size. That trick does not work for MSI installations. Windows will hang on to the files, which is sad face for everyone. So not space efficient. So avoid them if you possibly can. Coming up soon, and I forgot to link to them, but there are many blog posts out there that are way better than my take on Windows. I included one of them at the end, but Arun Gupta speaks a lot about Java and Windows, and then Elton Stoneman, who now works at Docker, who came from Microsoft. literally wrote the book, which was a funny joke, actually. He wrote the book on Windows containers on Docker. So if you're moving your Windows workloads over, or if you're looking for some tips on how to work with Windows and Docker, maybe check out the book on it also. So what's magical about running Windows containers as is on Windows Server? So you build and run everything exactly the same, regardless of the OS. So it doesn't matter what your tools are. It doesn't matter how you built it. It's just Docker build and Docker run. This is another GIF that's not so magical in PowerPoint. Thanks, PowerPoint. If anyone works in the PowerPoint team, I have questions for you. So he's usually saying magic. So please envision this GIF also in your head. This is Imagination Hour with Abby Fuller. This is actually really powerful. So it sounds kind of like, well, why is this person rattling on about Windows and Linux being the same? This means that regardless of how I built it, regardless of what language it's using, what operating system it's using, what tools the guy sitting next to me wanted to use, I can ship those little boxes exactly the same. So from a DevOps point of view, from an operations point of view, all I care about is those little boxes and how I can deploy them. I don't have to care about whether Team A wants to use Windows and Team B wants to use Linux. I can use the same tools to build and deploy those on my infrastructure. So let's look at some more Docker files. This is not the biggest I could have made it. For my example purposes, this is pretty big, right? And you can see why I'd write it this way. So if I was just getting started, or if I hadn't put much thought into optimizing, this would have been fine. So this builds, by the way. I ran my updates, and then I installed, I copied my app over, I did some requirements, I exposed my port, and I ran my app. So it is fine. Why is that not fine? So I have two different run statements. So once I've hit run, right, I've invalidated my cache. How can I make that just a little bit better? So I'm chaining my run statements together. So I update my packages, I install them all in the same line. So that means that my updates, my installations, they're all in the same place. And then I added another flag. So I always have people that come up after me, by the way, to these that say, did you know? And then they list 6 more flags. I know that there are other flags. I know that I did not include all of them. I'm going to start submitting a talk just for those people, and it's going to be 1 hour of command line flags, and that's all we're going to do. We're just going to exhaustively talk about every cool command line flag that I can think of. So I know that there are more, and I know that other package managers also have a version of no install recommends. Thank you for letting me know. Feel free to tweet it to me if you think that I've forgotten one. So no install recommends, though, for those of you that hasn't seen it, means that when many cases your package manager will recommend extras for you that it thinks you might need based on the package that you're installing. So this is pretty much the package manager equivalent that if I go to Amazon.com and I buy a book, it recommends me a million other books that I also might like. And in a lot of cases, I do like that, but that's not space efficient for my iPad either, and it is not efficient for my Docker containers. So if just to install the packages that I want, it's no install recommends, and by moving it to one line, I saved myself a little bit of space in my final image. This is the same one that we looked at before. I can change my base, and I can remove the operating system kind of setup lines, prepping it to run a Python application. But I can make this better. So I can write a custom base container. So in a real production life, not fake demo land, this is probably what I'd want to do in a lot of cases. So I built a custom base image, maybe from a full operating system, maybe from one of the minimal ones. I installed a lot of the packages that I needed. And now I don't need any other setup because I've done all of this setup in my base image. And you can go one step further, and I could make this a shared base image. So I could have several different containers build from that same base container. So I would be saving space on the final host as well because it has everything that I needed, and I can just run the separate applications on top of that shared base container. Here's a more exaggerated example of using my run statements effectively, but I can do everything plus the cleanup all in one statement. That means that I'm pinning my versions as well also, right? So if I don't need a different version other than that, I can pin it so it doesn't check for a new one, and I don't need to install the new one if the old one works just as fine, or if the new one has a security vulnerability in it. I can do that all in one line, though, to save space. There are some unintended things that also will add layers to your final image. So maybe a less well-known one is user. So we'll look at it with Node.js, but some languages will ship with that user for you already. But in a lot of cases, or most cases, you don't necessarily, although you might need to install things as root, you don't actually want to run your application as root. That's if there was a DevOps school or something, I'm sure that we would talk about that. But everyone finds it out at work, the old-fashioned way. But mostly you don't want to run your actual application as root. So if you're switching operations between different users, this commits a layer to the final layer. So every time you switch that user, it adds another layer to your stack. So in real life, what you'd want to do is anything that you need to do as root, you do first, and then you only have to switch once. So you don't have to switch from root to user to root. Make sure that you're installing things in the right order so that everything is grouped together by not only the right order, but by the user that you want to run the operation as. So if it's something like Node.js, use the Node user that comes with that official image, but you can just switch and then leave it once you need it to switch. The same goes for adding large files, right? So this is a really dramatic, bad example. Nothing if not dramatic. So I added my big file, I ran some install stuff, and then I ran make. Do not try that at home. That will take forever. What could be a little bit better than this? Well, that's not a real file, so it won't actually take forever, but this is like the least efficient way to do it. I could do it a little bit better, and I could do everything all in one line, but it's not the best. Now I can do everything in one line, but also I'm removing the zipped version that I downloaded. So we know that when we download a file and I unzip it, I keep the original compressed version, and then also the second unzipped directory, which is the contents of that zipped file. I can remove that zipped version, so the tarred version, I can remove that in the same line, and then I'm not committing that zipped file that I don't even need anymore to the final size of my image. So we'll talk about garbage collection in a little bit, but clean up your mess. So if you're downloading a file and you're using that file, get rid of it. If you're downloading a file and then using it to populate something else, get rid of the file. But you can do everything all in one line so that it doesn't commit back to the final image size. A couple of really lightning language examples. So if you stop paying attention right now, here's the TLDR of what we're talking about, right? So use the right tool. So not every language will build the same way. So just because I built something one way and Boaz is using a different language, he does not have to build it the same way, right? We talked about why that's cool, because I can just drop those little boxes and deploy them the same way. Use the right tools, because it ultimately, once you've built it, it doesn't matter. We'll look at more examples, but where possible, I can use two images. So one to build the artifact, and then a really lightweight one just to run it. And then official languages can be really big for good reasons. So more space effective, but possibly less time effective to use a smaller image and then do a little extra work to get it up to where you need it to be. So there are some very small examples here for everyone. This does not constitute a real-world production experience, by the way. These are just examples. So if you're actually doing this at work, these are some tips that might help you, but they are not an exhaustive resource. So for every example that I've done, there's a blog post or something out there by someone that runs this language in production. So definitely do a little bit more reading on it also. For Golang, though, I can run this in two steps, right? So I can do my Go build step, and I can build my file from that. And then I can run just that binary, that artifact, in another really, we'll talk about what Scratch is, but in a very lightweight image. So all it needs to do, it doesn't need a tool chain, right? Because it's not building. I've already built the artifact. Now I can just run it somewhere else. Also, I couldn't leave out Golang because the gophers are really cute. If you've never, what? Yep. If you've never worked with Scratch before, it's a special empty Dockerfile. I included a link to learn about it. It's actually really cool. It has nothing in it. It's basically a special command that says, I'm empty, and you can use it as either a minimal image or just to run a binary. It's actually really interesting. So definitely check into it if you want to run binaries that you built in other ones. We already talked about Ruby, so this is the same. This is just an example of it. They're really huge because of all the extra gems. You can use a minimal image, but you'll have to install all the supporting gems that you need, which in Ruby world means that I'll have to keep trying to build it over and over and over again and looking at the gem error until I figure out what magical missing mystery gem it is. We already talked about the user part of the official node images, but you can also Docker ignore things just like you can git ignore. So you can ignore your npm debug log, which will turn out to be secretly really large and wasting you a lot of time and space. But you can also cache your node modules. So the same way that we could cache our requirements in the Python app, I can copy over my package.json first so that I only run it if the contents of that file have changed. So Java, this one and the next slide are both on multi-stage builds. So I can run these in two different pieces. So I can build my artifact in one step and then run only the binary in the second stage. So it makes a more minimal image because I've moved all of my build steps, all of my toolchain steps out to the first one. So that's extra great for things like Java that you usually build with like a Spring or a Maven. Those are very large, but I can move all that to the first part and then just run the result. More on multi-stage builds. I included some links at the end, by the way, to whatever we covered in here that you'd like to research some more about. Multi-stage builds can be really great for things like Java or Go. My last thing up, we're on tools. So how can you, but mostly me, do less work, which I'm pretty sure is called thought leadership. So this is not an actual tweet, by the way. I faked this, but it is thought leadership. But how can you do less work? And the answer in a lot of cases is tools. And I know that there are a lot of tools. So it's really a case of picking the right tools. So you have something called Docker Security Scan, which will scan images up on Docker Hub. You can use this privately, but it also works for official ones, where you can basically check and see if the image that you're using has vulnerabilities. So spoiler alert, a lot of them do. So use responsibly, download strange things from the internet responsibly. Image and system prune. Image will remove unused images. System prune will also remove unused volumes. So clean up after yourself, but that also includes garbage collection. So beyond image and system prune, there are tools that you can run to help make sure that all of your unused images aren't just sitting along after all of your builds, taking up all of your hosts. There's some good third-party ones out there too. So Spotify GC is one of them. If you're from Spotify and you wrote Spotify GC, you're awesome. So looking forward to the future, there's always more. People do make, lots of people like talking about this, so there's lots of blog posts out there. People are making their minimal images even more minimal all the time. So what did we learn here, right? So if you have one takeaway, it's less layers is more, so share them where you can. Choose and build it wisely. Build all of your languages the way that they should be built and not just the same way. Keep it simple, and then some tools, but only the right ones, are here to help. As promised, we are out of time. I've included the useful links, so when the deck goes up, either through DevOpsDays Tel Aviv or through me, you can read at your leisure, and thank you for listening.